Third question. This is use a definition of trigonometric identities and the Pythagorean, or the distance formula, to simplify the following two trigonometric expressions. So there are all sorts of rules that you can learn, and you're welcome to use them. Like 1 minus cosine squared is sine squared. You can just go ahead and replace 1 minus cosine squared with sine squared if it's something you happen to know. But what I like about mathematics is that you can build up from knowing very little. And so that's the tools that I will like to train you to use. If you use other tools, that's fine. Okay, so you know from the previous example, if you just did problem 2, you already have sine, cosine, tangent, cotangent, secant, cosecant. All those formulas are written already, and they're probably on your 3x5 card anyway. So I'm just pulling them off of there. Okay, sine is y over r. Tangent is y over x. Cosine is x over r. So all we're going to do is we're going to reduce this. The first thing I'm going to do is multiply by r squared over r squared, because what I want to get rid of is this denominator in the denominator. I don't like stacked denominators. Who likes stacked denominators? Not me. Okay, so let's do that. At least this will help simplify this. And I'll also get rid of some of this mess up here. So I'm going to get r squared y over r, y over x on the top. On the bottom, I'm multiplying through by r squared. I get r squared minus x squared. So at least I'm making some progress. So I'm going to get rid of 1r over here. So I'm going to get y squared over rx all over r squared minus x squared. Okay? Well, we know x squared plus y squared equals r squared. Therefore, r squared minus x squared must equal y squared. Okay, so we've got a y squared downstairs. We have a y squared over rx. And that's actually going to get rid of, actually no, I have a y squared, the r is in the numerator, sorry, my bad. This isn't going to work if I do it that way. Yeah, see, the thing is, this r is still in the numerator and this x is in the denominator. The y squares are in the right place. Okay, this structure is going to get rid of those y squares, and I'll show you why. Because if you did y squared over 1 and then you did y squared times r over x times, and you flip and multiply, you get 1 over y squared, then those cancel. Okay? So if you understand the stuff I wrote in blue, then you don't have to write it. You could just cross off the two y squares and move on. But if that step was confusing, just write everything out. We finally get r over x, which is secant of t. Again, if you wanted to speed up your work by replacing 1 minus cosine squared with sine squared, which is the traditional way to teach these questions, you're welcome to do that. And then you get sine, one set of sines cancel. And then in that case, you've reduced the amount of work, and then you're just going to have tangent of t over sine of t, and then you can just go ahead and say tan is y over x, sine is y over r, and then you're going to end up with the same, relationship again, y over x times over y. You're still going to have to flip and multiply. You're still going to end up with r over x, but it would save you some work. So you have two paths or more, but at least two paths to the correct answer. And but the red is explaining how you can do it with memorizing the minimal amount of information. But if you happen to already know this fact about 1 minus cosine of sine squared, then you can save yourself a couple steps in the process. Right. Let's talk about this one here. Cosine squared plus cosine squared times cotangent squared. So you can factor out cosine squared first if you would like to. Alright. It's not necessary, but you can do that. And I'm going to not do that for now. So cosine squared is x squared over r squared. And then you get x squared over r squared again, and cotangent squared is x squared over y squared. So we've converted everything to x, y, and r. At this point, I am going to go ahead and factor out the cosine squared, but it's now looking like x squared over r squared when I do it. Okay? Now what do I do? Well, something's a mess. And one of the things that's a mess is the fact that we have this y squared I don't like down here. So I'm going to multiply by y squared over y squared. And there's more than one way to attack this, but this is just what I'm planning on doing here. And so what's going to happen is I'm going to get x squared over r squared, and this y squared is going to distribute through, and so I'm going to get y squared plus x squared all over y squared. And aha, why did I do this now? You always, at some point, you have to still use the Pythagorean theorem. None of these questions are going to work unless you make use of this magic formula. Since x squared plus y squared equals r squared, this is r squared. And so now I can cancel these guys. Yay! Now I can tell I'm out of the woods, because now I have x over y squared. And x over y is the reciprocal of tangent, right? So it's really cotangent squared of t. Okay? Hopefully that was pretty straightforward for you.